are two or more inequalities that are joined together by and or. So that's what we're going to put there at the top of that section. So we're going to write two or more inequalities. Joined together with and or. And I know that or sounds weird, but we're just going to go with it today. So, one thing about compound inequalities, there are two types. Okay, we will have an and type and an or type. We're going to start with the type 1, which is our or inequalities. So or inequalities have a tendency to graph apart. And that'll become apparent what that means when we see the picture of the graph. So first thing here, we're going to look at x is less than negative 2. So to graph x is less than negative 2. At negative 2, do I need an open or closed circle? Closed. Then does it need to go to the right or to the left? Left, because it is less than. Now we're going to look at, or let's go ahead and do the interval notation for that. How would I write the interval notation for that piece? There we go. Remember, we do it in the same way that it is from left to right. So our arrows tell us where infinity goes. So if the arrow's on the left, infinity's on the left. If our point's on the right, the number's on the right. Now we're going to look at x is greater than 3. And honestly, I'm going to rewrite the 3 right here just so it makes it look a little bit better. So x is greater than 3. So at 3, do I need to do open or closed circle? Now, is that going to go to the right or to the left? To the right, because it is greater than. So that is what that section's graph looks like. Now, how would I do the interval notation for that piece? Parentheses. There we go. And so the reason it says they graph apart is because both ends of that graph go in separate directions. They are going apart, each end. Now, in order for us to join together our interval notation, we are going to use a union, which is just a math symbol we use in the place of or, okay? And so whenever we're talking about the solution to this, we're talking about it can be on one side or the other, okay? But it can't be in the middle, essentially is what's happening. So can negative 7 be a solution? Yes. Can 5 be a solution? But can 1? No, because it's not on either of the graphs. So when we have an or inequality, it has to be on one or the other. Now we're going to actually look at equations with these types of graphs. So honestly, when we have or inequalities, it's the same thing as regular inequalities. It's just we're putting two on the same graph together. So we're going to look at number 1. So we're going to start with x minus 4 is less than negative 7. How do I solve x minus 4 is less than negative 7? What do I need to do to solve that? Plus 4. So we get x is less than, what is negative 7 plus 4? Negative 3. Then let's graph it. To graph that, do I need to go, for negative 3, open or close circle? And then does it open to the right or to the left? So to do the interval notation for that piece, what would I do?
Negative infinity.
We do the negative infinity and -3 with parentheses on both sides. Now we're going to look at the other half. So we're going to look at 2x is greater than 12. How do I solve that? Divide both sides by 2. So we get x is greater than or equal to. And it's 6. Do I need to open or close circle? Yeah, because it's got that or equal to piece. Anytime it adds that or equal to piece at the bottom, that gives us a closed dot. Now, does it go to the right or to the left? So that is what our graph should look like. And how do I do that blue piece's interval notation?
Bracket 6.
2 in. How do I connect the two? Like possible solutions. So by us finding this part, or let's look. So this part here, okay, if we look at that, that is giving us our answer as a inequality notation. So on the Delta Math assignment, that's the notation it asks for, is your inequality notation. Then we have our graph, and we have our interval notation, okay? All of these different types of notation can be considered showing the solution. So like we write the solution like this, or we can write it like this. So we are writing the solution, it's not what we think of as a normal, easy, like one-term solution. It's a lot of terms, yeah.
So it's just like condensed into that?
So we're taking it and condensing it to the most minimal answer we can, which is x is less than -3 or x is greater than 6. All right, for number 2. For 2x plus 9 is greater than 7, how do I solve that?
So just the 9 and then the 5.
So we get 2x is greater than, what is 17 minus 9? And then what do I do? You said divide by. So x has to be greater than 4. Let's go ahead and solve the other one before we graph it. So to solve 5x plus 10 is less than 10. How do I go about solving that? Minus 10 on both sides. So I have 5x is less than, what is 10 minus 10? Now, to get x by itself, I have to divide by 5. What is 0 divided by 5? 0. So that right there is our answer. X has to be greater than 4 or x has to be less than 0. So let's graph both of these. So if we start with x is greater than 4, do I need an open circle or a closed circle? Open. Does it need to go to the right or to the left? Now we're going to look at x is less than 0. So at 0, open or closed circle? Does it need to go to the right or to the left? To the left, because it is less than. So this graph, okay, which piece do I need to put first in the interval notation? The green piece or the blue piece? The green piece, because it comes first left to right. We go left to right every single time, okay? So let's do the green piece's interval notation. How would I write the interval notation of that? Parentheses or bracket? Parentheses. And then the blue piece. Parentheses to infinity. And then how do I join the two? And so that would be how we would do this problem. Now, number 3, I have a typo on number 3, and you can solve it. Ooh.
There's no water in it.
I'm so glad. But you can solve number 3, but it's not an or inequality, so we're just going to skip it. And we're going to go ahead and talk about and inequalities. Okay, so type 2 is and. So and inequalities have a tendency to graph together. So we're going to look at these. Now, I also had a typo right here, so we're going to fix this real quick. That is supposed to say x is greater than -6. I learned my lesson on printing before working out my keys. So. Now, we're going to go ahead and we're going to graph the first piece. We're going to do x is greater than -6. So, actually, I'm going to change color of that. X is greater. Oh, good gracious. X is greater than -6. So, I'm going to go on my graph to -6. Do I need an open or closed circle? And then does my graph need to go to the right or to the left? Right, because it is greater than. Now, we're going to do the second piece. So we're going to look at x is less than or equal to 1. So at 1, do I need an open or a closed circle? And then does it need to go to the right or to the left? To the left, because it is less than. So that is what our picture looks like there. So if I'm talking about a solution to where it is both greater than -6 and less than or equal to 1, am I talking about this part of the graph? No. Am I talking about this part of the graph? No. I am talking about the part where they both overlap. I am talking about that middle part there, where the graphs come together. That is what I'm looking at. When I graph these, I don't have to put the pieces out to the side. All I have to put is the pieces where they come together. Okay, so that makes graphing these actually the easiest. And I think that if I had to pick a type of inequality, like out of all of the types of inequalities we're going to look at, ands are my favorite. So to do interval notation of these, does this graph on either side go to infinity? No, it has a point on both sides. So that means we're going to have a number on both sides. So first, we have this point here. That's an open circle at -6. So I'm going to go from -6 with a parentheses or bracket. And it's going to go to bracket, but it's going to have 1. So it just does just the points. From point to point is what our interval notation does. So it doesn't go to infinity. No worrying about that. And no worrying about u's. Okay? And our graphs just connect together. That's what we say when we say and inequalities come together. And that's the difference between them and ors. Ors, graphs go apart. The ends point in opposite direction in an or inequality. Whereas with an and, it's just the part that joins them together. So we're going to look at a couple of these. But before we do, we're going to talk about how sometimes they're not always going to be written with and in between. Actually, almost never will they be written with and in between. So far, we've looked at the graph of x is greater than -6 and x is less than or equal to 1. So there is a way to write that more condensed down. So we only have to write one piece of information. So here, do you see how the solution is in between the 2 points? We're going to do that same thing with our inequality notation. So we're going to go from the smallest point to the biggest point. So -6 is the smallest. So we're going to -6 is less than x, which is less than or equal to 1. We're just writing it as an inequality that shows that your solution is in the middle. That's all we're doing. The solution is what's in between the two. Or this is literally the line that connects them. And so a lot of the equations we have with and inequalities are written in this format. We'll almost never see the word and written out in a problem. And so for number 4, we're going to actually look at that. Now, there are 2 strategies that we can look at to solve an and inequality. Okay? So first, we can write it as 2 full separate inequalities. We can do 2 is less than or equal to x plus 4 and x plus 4 is less than 9. That is a strategy for solving it. The other strategy is us leaving it like it's written. So 2 is less than or equal to x plus 4 is less than 9. So if we are to split it up into 2 separate equations, we solve those just like normal, okay? So how would I solve 2 is less than or equal to x plus 4? Subtract 4 on both sides. 2 minus 4 is? Negative 2. Is less than or equal to x. Then we do the same thing for the other one. So we have and, then for the other one, how do I do that? Subtract 4 on both sides. X is less than, what is 9 minus 4? 5. So that's strategy 1. Strategy 2 is where we leave everything where it's at to begin with, and we just move things twice. So over here, I still have to do what first to solve for x? So when I subtract 4, I'm going to do it on all of our inequalities. Just do it there. Now, if you're a person that gets confused with stuff like that, some students like to draw little lines to help them keep everything straight. So do what you need to do to help it make sense to you. Okay, I do not care which method you use. I'm good with any of them. What is 2 minus 4? So we have negative 2 is less than or equal to, or not 0. What is, we just have x in the middle. Yep. And then 9 minus 4 is 5. I personally like if I'm doing the problem myself, I leave it that way just because now my answer is already written for me. So at negative 2, I do an open or close circle. At 5, do I do an open or close circle? And then since it's an and, they go together. Now, which method, if you like method 1, raise your hand. Okay. If you like method 2, raise your hand. Okay, cool. I ask because I try to do the method on the board that the most people like. But if you like method 1 and you want to split it up every single time, do that. Do the way that makes the most sense to you. You do not have to blindly copy everything I put on the board just because I put it up on the board and that's the way I like to do it. I'm trying to show you multiple ways to do problems. If there's a way that makes more sense in your brain, use the way that makes the most sense to you, okay? So from here, let's do our interval notation. So is there any infinities in this one? So we go from our points from left to right. So what is my left point? Negative 2. Does it get a parentheses or a bracket?
Bracket.
And it goes to?
5.
Parentheses or bracket? There we go. But I honestly like and inequalities the best just because I think graphing them is the easiest. Putting their inequality notation is the easiest. And I feel like it's less work than or inequalities for some reason in my brain. I just like the and ones. But both are very easy and very straightforward. So let's go ahead and look at number 5. Okay, for number 5, how do I go about solving this one?
13 to both sides.
So I'm going to add 13 everywhere. If you need to split it up, split it up. Now from here, we get negative 27 plus 13. What is that?
Negative 14.
So we get negative 14 is less than 7x is less than 8 plus 13. 21. Now, how do I solve that for x?
Divide by 7.
Divide everything by 7. What is negative 14 divided by 7? Mm-hmm. Is less than x is less than 21 divided by 7? 3. So we are good to graph now. So at negative 2, open or close circle.
Open.
At 3, open or close circle.
Also open.
Okay? Since it's an and inequality, does it graph together or apart? Together. So we just connect them.
Wait, when is it not together?
Or. Or goes apart. And then for interval notation, how would I write that?
Parentheses, -2. Parentheses.
There we go. Just like that. All right. We're also going to do number 6. Okay, before we do number 6, I want us to look over. You do not have to write this. In fact, it probably will confuse you if you write it. If I give you this question, 5x plus 1 equals 11, how do I solve it?
-1.
And so I get 5x is equal to 10 divided by 5. Okay, that same strategy is what we use here. Okay, even though that fraction's there, we still have to move the +1 first. So what do I do to solve this? -1. So -1 minus 1 is
-2.
is less than
2/3.
Is less than or equal to.
4.
Now, how do I get rid of a fraction?
Times by 3.
That gets rid of just the denominator, but I want to go ahead and get rid of the whole thing. So it is multiplying by the reciprocal. What is the reciprocal in this case? Now, if I want to make a whole number into a fraction. Uh-oh, what did I do wrong? I haven't. 5. What is that supposed to be right there?
4.
It is supposed to be a 4. Because 5 minus 1 is...
Put a 1 under it.
We're going to put 1s under them to make it easier to multiply. You'll have to be on the lookout. If I make a mistake, tell me. Because I'm human. Now let's multiply these fractions. 3 times -2 is...
-6.
2 times 1 is...
-2.
So we get -6/2 is less than x is less than or equal to... What is 4 times 3?
12/2.
Then can I simplify those?
Yeah.
What is -6 divided by 2?
3.
Not just 3.
-3.
So -3 is less than x is less than or equal to 6. And we are good to graph. -3, open or close circle? Open. At 6, open or close circle?
Open.
Oh?
Oh, wait.
Anytime we have that or equal to line, that tells us it's going to be closed. And then does it graph together or apart? And then how would I write that in interval notation? 6 bracket. And so that is compound inequalities. Okay.